Hi all, and thanks for joining in to this session. My name is Janne Liuttu, and I'm leading Ramboll's analytics and data science practice. And I will be telling you a bit about our AI journey and especially how sustainable development has been one of the drivers for digitalization in our industry. Unfortunately, I won't be joining you physically to the event this time, but please go ahead and connect with me on the event platform or LinkedIn or Twitter, and really happy to continue the discussion around these topics. Just a few words about Ramboll to give you a bit of context. So we are a global civil engineering group and doing pretty much anything when it comes to our physical environment. So we are designing buildings, bridges, airports, water treatment plants, you name it. So any kind of assets that are within our built environment, and of course as a global and company operating in very many different business areas, the maturity within AI is of course varying across our organization, and we have some areas where we have already really advanced solutions, and of course a lot of areas where we are just getting started. And maybe one good thing to mention is that of course the industry is of course among the least digitalized industries. So of course many of the things that have been done in many other industries are kind of new to us. So of course it has been an interesting journey over the last years to build this up. But if we look a couple of pointers from the latest research around sustainability, that what we are seeing that different organizations are now setting their sustainability targets, and this is done on very different levels. So starting from global sustainable development goals set by the UN, and then national governments are implementing their policies and local regulations, and cities and municipalities, and of course also companies are setting their sustainable development programs. And what we are seeing that many companies are actually setting targets that go way beyond what's required by the regulation. So it is not just compliance for the companies. So companies are actually seeing sustainability as a competitive advantage, and of course this is coming from the clients and consumers that are requiring companies to operate more responsibly, and of course this is a big change, but also a big opportunity for companies going forward, and this is what we have seen, that it's also a major driver for our industry to become more sustainable, but also drive the digitalization in our operations. And if we look at our industry, of course there is a point there that why sustainability is such a big topic. So we have a lot to improve there. So this is from research some time ago, that it was estimated that roughly 40% of all global CO2 emissions are coming from buildings and construction. So this is a huge number. And another research was that 50% of physical waste is connected to construction industry. So of course our industry has a lot to improve, and if we are able to improve the way that how we do things, this has significant impact not just on the companies operating in this industry, but the overall society. So of course it's a kind of a big opportunity for us to improve. And if we look at a bit of the challenges that are related to this, so this is a really simplified approach to the life cycle of the built environment. So regardless of what kind of assets we are dealing with, then the process is roughly the same, that we start with planning, and then we are constructing it, and then it's commissioned into use, then used and maintained, and after some time it's refurbished, and maybe at the end of the life cycle then demolished. But if we look at the time frames that are associated with this, then usually, of course this depends a bit on the project, but usually it's somewhere between 3 to 10 years from the beginning of the planning to the actual commissioning. And regardless of what physical assets we are dealing with, usually the plant life cycle is at least 30 years or even more than 100 years. So of course the time frames are really long, and the decisions that we do early in the process have a significant impact at what happens later throughout the life cycle. And of course another challenge is that usually it's different stakeholders involved in these different phases who have different interests when it comes to the overall process. So of course this is also a big challenge because the overall value chain is rather fragmented within our industry. And as mentioned, so basically when it comes to assets in prime locations, the life cycle can be hundreds of years, and if we are talking about prime location real estate, it's more or less there indefinitely, and the renewal rate of our built environment is rather slow. So if it's 100 years, then roughly 1% is renewed every year. So we need to look into the existing infrastructure as well, and not just the new build. But when it comes to AI, of course this brings one challenge, that how we get data to train AI, since the kind of outcomes that we are looking can be somewhere in the decades or even longer time. So this is very different from many other industries that where the feedback is instant. For example, in online advertising, that we see right away that how the customers are reacting to the ad. But here we need to deal with much higher uncertainty and kind of longer time frames, and of course difficulties to get the data, since of course the physical environment comes with its own challenges. But of course maybe we cannot solve all the problems at once, but just improving over the baseline can have significant improvement, as mentioned before, that if we are able to do things more sustainably, then this can have a significant impact. Another challenge that we are seeing, that quite often the projects are becoming increasingly complex, and there is more stakeholders, more regulation, more requirements to satisfy, and of course this is another challenge, and of course we are world is getting more urbanized as we go, and there is only so much space in the center of cities. So in the picture, this is one really nice example of this from city of Tampere in Finland. So actually our local office is in one of the buildings in the background, but a huge arena with couple of high rises constructed in the center of city on top of existing railroad that's continuously operated while we build. So hugely complicated project with a lot of things to take into account, not just logistically, but how to fit all of this together. And of course this is a special case, but we are seeing that projects are getting bigger and bigger and more complex, and that's adding additional challenges to this process. But then if we look at it from the other perspective, the assets that we are constructing, they are increasingly smart and are actually producing extensive amount of data. So our buildings are not just concrete and plumbing, but they contain a lot of sophisticated smart technical systems that are controlling the performance and operations of the asset, and also what we are seeing that we can then get access to this data and analyze the performance. So in the picture you can see our new Finnish headquarters. It's not just physically green building, but actually green in a way as well, that it has a kind of modern system that are controlling the indoor environment and energy consumption and everything, and we have designed almost everything there ourselves. So of course we have a lot of data already from the really early stages of the design up to operation that we have been there for a couple of years, and that kind of gives us the opportunity to analyze that how the different decisions that we do throughout the design process then is seen in the actual operation of this building. But if we look then that what has happened to the profession of engineering in the last years and decades, so of course in not that many years or decades ago, then this was something that was done with pen and paper. So we still have the saying of going back to the drawing board, and a couple of decades ago this meant actually going back to the drawing board and doing the adjustments with pen and paper. And then over the last decades, computer-aided design software has been coming along. Of course, this has been around for quite a long time, and the software has been becoming more and more smart. But basically, the process has been more or less the same. That eventually we are just drawing with the computer instead of the pen and paper. But now things are getting more interesting as we are progressing towards algorithmic and generative design. So there we are not drawing the outcome, but we are defining the process that how this is designed. So if we define the logic ourselves, we call it the algorithmic design, and then if we just give some objectives and constraints and let the computer then to optimize according to those, then called generative design, and then there things start to get really interesting, since then the kind of whole process is in the as a more or less code, and if we need to change something, we just change parameters and then just make the computer do the work in the digital world. And if we are looking at what kind of solutions come out of that, if we look like strictly from the physically optimal perspective, then these are quite often kind of more like biological forms in the structures, and now that we have 3D printing and other enabling technologies that we are actually able to manufacture these as well. So this is a big opportunity in the future. At the moment it's mostly applied in the manufacturing, but we are seeing more and more like more large scale applications of these, and it will also have significant impact in the future. So if we then combine these, that okay, we are digitalizing the way that we design and doing more in the digital world, and once we have the physical assets, then we have data coming back from the asset. So basically, to put it really simply, so then the AI and different simulations enable us to then predict that what is the actual performance of the asset, and make informed decisions in the early stages of the process. So of course some of this is something that we can simulate physically, since quite often the physics are pretty well known, and then we have some areas that where there is more randomness, then we need to utilize some form of analytics or AI to make the predictions. But anyway, that we can do more in the digital world, and then try to predict as much as possible that what happens in the physical world, since of course in the digital world it's cheaper to do some adjustments, and once we have constructed something, it's really difficult to then do at least any fundamental changes to what has been done, or at least it becomes really expensive. And then we have the data collection from the physical assets that enables to make a feedback loop for the AI and simulations, and validate the outcomes of our design choices, and doing this systematically brings us a kind of big opportunity to really optimize the way that how we design, and what kind of systems and structures we should be putting to our assets, that they are performing in as sustainable way as possible. And of course this is then that we can basically any decisions that we do in the design process validate with simulation and measurements of the actual performance, and in some cases also kind of go on site with some virtual reality solutions. For example, of course, the technology has been there already for quite a while, but now it's getting more cost efficient and able to do a much larger scale, and we are able to take much more aspects into account when doing the analysis. So maybe before it was more just making sure that our physical aspects of the assets are intact. That of course we don't want any of the structures to collapse or anything. But now we can take much bigger variety of aspects into play when we do the analysis. And of course, this is then where the kind of sustainability aspects come in. So we of course need data to evaluate the sustainability of our businesses and operations. So just like we are using financial metrics to evaluate the business performance, so we need sustainability metrics to evaluate the sustainability performance, and of course this goes to different levels from the companies and business level to then individual operations, and when we think of abilities assets to individual components within the assets that we are producing, and this is really giving us the opportunity to look into different aspects of our projects and optimize towards better solutions. So to just maybe to wrap it up and summarize, so basically what in essence AI is helping us do is then balancing between these different objectives of the project. So when I joined Ramboll a couple of years ago, I had a saying that only the cheapest is good enough. But these days it's not. Of course, we need to look into the price as well. So, but we can look at holistically into these different aspects of the projects, and we still of course need to deal with the economic realities and constraints and make sure that our structures are in place. But now we can look also at the environmental impact and stakeholder needs to then select the solutions that are filling the strategy of the project, and then select that what is the kind of trade-offs between costs and environmental impact, and make informed decisions based on these. So that was just some quick thoughts and high-level overview of some of the things that we have seen in our AI journey and what kind of things we are seeing in our industry. Of course, many of these might sound a bit trivial for people in other industries, but when we are dealing with physical environment, then of course we have much more constraints and much more challenges when it comes to collecting the data and utilizing it systematically. But anyway, as said, unfortunately I won't be attending physically, but please go ahead and connect on the event platform or LinkedIn or Twitter, and really happy to continue this discussion there. But yeah, thank you all for joining in, and have a great event. Bye.